Okay, so we're just going to pick up where we left off. I think this is where we left off, talking about slope. So the slope of a line is a measure of how steep the line is. And basically, it is the ratio of the rise of that line over the run of the line as we go from point to point. This delta y over delta x, that's just another way of saying the change in the y over the change in the x as you go from one point to another point. Another way to say that is the slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. It just means the difference in the y coordinate divided by the difference in the x coordinate as you go from one point to the other. And so you can see a better picture of it. Vertical change divided by the horizontal change, that is what we call the slope. So positive slope as you go from left to right on the x-axis, it's going to be going uphill, and a negative slope as you go from left to right on the x-axis is going to be going down. If you want to find the slope of a line that goes through 2 points, all you have to do is write that slope formula. So you're going to write the change in the y's. So here we have 5 here, and then we have a negative 2 here. So the change in the y coordinates is 5 minus negative 2. That's in your numerator. And the change in the x coordinates are 2 minus negative 3. And so that's going to be 7 over 5. So that would be the slope of a line through those 2 points. Okay. Finding the slope of a horizontal line. If you think about this, you don't really have to use points like the book does. You just have to see that every single point on this line has a y value of 3. It never goes up. It never goes down. It just has the same y coordinate the whole time. So there is no rise for this particular line. So if you're writing rise over run, this line just has run. It doesn't have any rise. So it's going to be 0 over, it doesn't even matter what that is because 0 over any positive number is 0. So a horizontal line will always have a slope of 0. The vertical line, you can see on part B, has rise, but it has no run. It never goes from left to right. So in that case, you have, whatever you have for the rise divided by no run. So 0 for the run. And of course that, it is undefined. Okay. So we would say that for a vertical line, there is no slope. Okay. So for example, 4, you are using the slope and y-intercept to graph a line, which we already did. You just take that line and you put it into the form y equals mx plus b. And so we have this equation, 3x plus 4y equals 4. If we isolate y, we will have 4y is equal to negative 3x plus 4. And if we divide through by 4, we will get y equals negative 3/4 x plus 1. So this is our slope. This is our y-intercept. So if I just graph my y-intercept, which is 1, I can use the slope to find other points on this line. So we are going to go down 3 and to the right 4. One of them has to be positive and the other has to be negative. So if I go down 3, I need to go to the right 4. And if I start back at that y-intercept and I go up 3, I have to go backwards 4. And so that line is going to look like that. And drawing a line with this thing is really hard. So anyway, it's going to look like a straight line like that. Now we're going to talk about linear functions. We've been talking about linear equations. It's very similar. It's not much different, but there's just one small thing that is different. So if you let m and b represent real numbers where m is not 0, then a function defined by f of x equals mx plus b is called a linear function. The graph of a linear function is a slanted line because you notice it says that m is not 0. So the slope is not 0. So it's either a positive number or a negative number, which means you're going to have a slanted line. You're going to have a line that has some kind of slope to it. A function defined by f of x equals b is what we call a constant function. That function is just like y equals 2 or y equals 3. It's just a horizontal line, and it doesn't ever change. It has the same value the whole time as far as the f of x, the y coordinate. And so we call that a constant function. We're not mentioning functions that are vertical lines because, of course, a vertical line does not represent a function, because we talked about the fact that a vertical line will have all different kinds of y's being mapped to just one x coordinate, one x value. And so a vertical line is not even a function, so we don't mention it. All right, so writing an equation of a line given a point and a slope, that is something you've done probably a million times, but I will go through it. The slope is -4. So my line, y equals mx plus b, is going to look like this with a slope, that's your m, and then your y-intercept you don't know yet. So you're going to use this point to figure out what that y-intercept is. So y would be -3, and x would be 2. And if I go ahead and multiply that out and isolate b, I'm going to have -3 plus 8 is equal to b. So b would be 5. And so now I have my m, I have my b, and I can write my equation. Y equals m, which was -4, x plus b, which we found out is 5. So this would be the equation of that line, and they want me to write it in function notation. And so function notation would be f of x is equal to -4x plus 5. Okay, so this is a little bit new, this idea that another way to think of the slope of a linear function as the rate of change of that function. So you can see for this first line, it has a slower rate of change. And what that means is as you go along on the x-axis, y is changing very slowly. I mean, you go all the way this far, and y has not changed much. It was 0 here, now it's like maybe 2. All right, on this line over here, it has a faster rate of change. It's going from here to here, and y has changed a whole lot by the time you get here. So you've gone a shorter distance even than you went over here, and y has changed a lot. It's gone from 0 all the way up to here. So that is a faster rate of change. Okay, so when we have a curve like this, we have a function, y equals f of x, and we want to find the rate of change from some point on the x-axis to another point on the x-axis, some interval. We're trying to figure out what is the rate of change. Well, this is a curve, and so the rate of change is changing all the time. It's not the same anywhere on there as you're moving along. It's always changing. And so you can't really find the exact rate of change, but you can find the average rate of change on a certain interval. So the way you do that, if you want to find out the average rate of change between x of 1 and x of 2, is you draw a secant line, which means it's a line that goes through 2 points on the function. So there are 2 points, the point at x sub 1, f of x sub 1, and the point at when x is equal to x sub 2, f of x sub 2. So you've got that secant line. If you look at the slope of that line, you will know the average rate of change on that part of the function. So remember, f of x just means y. F of x is the value of the function at x, at whatever place on the x-axis you are, and that's just the y coordinate. So the slope of the secant line is the average rate of change of the function on that interval from x sub 1 to x sub 2. And so that's the slope. It's the change in the y's divided by the change in the x's, and that is the average rate of change. Average rate of change of the function y equals f of x on that interval from x sub 1 to x sub 2. That is what that is. Okay, so if we wanted to compute the average rate of change in this problem where we're talking about blood alcohol level, and we're talking about what is the average rate of change as you go from 0 hours when you first drink to 1 hour after you did that. How would you figure that out? Well, all you would have to do would be to look at the 2 points. When x is 0, you're at 0, 0. So you've got these 2 points, 0, 0. And the other point is right here. When x is 1, y is 0.06 or 6%. And so you're looking at the secant line that connects these 2 points, 0, 0 and 1, 0.06. that secant line, if you find the slope of it, then you will find the average rate of change that's happening between 0 hours and 1 hour. So you would just do the slope formula, 0.06. And that's just telling you that as you drink something, by the end of the first hour, you will have raised your blood alcohol level 6%. 6% per hour. That's the rate of change during that interval from 0 to 1. For part B, the rate of change from x sub 1 equals 1 to x sub 2 equals 2, now you're talking about the rate of change of your blood alcohol level as you go from the first hour to the second hour after drinking alcohol. All right, so what's going on here? What are the 2 points? Well, at x equals 1, we have that point 1, 0.06. And when x is 2 hours, we are up here at 2, 0.09. If we find the slope of the line that connects these 2 points, so this bluish greenish line right here, that will tell us the average rate of change of your blood alcohol level between 1 and 2 hours after drinking. So that average rate of change is just the slope. So 0.09 minus 0.06 divided by 2 minus 1, and that is just going to be 0.03, so 3% per hour. So you started out where your rate of change was 6% per hour. Now it's dropped to 3% per hour. And so that's all that, part C says, what is this, interpret the results. And it just basically tells you that during the first hour, you could say something like during the first hour after drinking, your blood alcohol concentration is rising by 6% per hour. That's the rate of change. And then for part B, you would say between the first and second hours, it has slowed down to about 3% per hour. Okay, computing the average rate of change here, you've got a function f of x equals x squared minus 1, that blue curve, determining the average rate of change from x sub 1 equals negative 2 to x sub 2 equals 0. It's the same thing. You are just looking at 2 points on this function, the blue function, the parabola. You're looking at the function, the value of the function at x equals negative 2. So when x is negative 2, that's the value of the function is 3. And you're going to x sub 2 equals 0. When x is 0, the value of the function is negative 1. And so if you draw a line, a secant line through those 2 points, you'll be able to tell the average rate of change of this function on that interval just by finding the slope of that line. Okay, here we're talking about solving equations and inequalities graphically. All right, that means tell me what's happening with a picture instead of just showing me algebra. All right, so for part A, it says solve this graphically. All right, so you've got 2x minus 3 equals x minus 1. And so when it says graphically, it means show me where this line, y equals 2x minus 3, has the same value as this line, the line x minus 1. So you've got a picture here of the 2 lines. This is y equals 2x minus 3, the blue line, and this is y equals x minus 1. It's the purple line. So I graph these 2 lines, and I show where they have the same value, and that happens right here where they cross. That's when they have the same value. Remember, when I'm talking about the value of the function, I'm talking about the y coordinate. Part A, these 2 functions have the same value when x is 2. For part B, for what values of x is the blue line below the purple line? So when does that happen? Well, that happens when x, from the point where x is 2, all the way down forever. From that point to the left, the blue line is always below the purple line. 2x minus 3 would be less than x minus 1 on that whole interval from 2 down to infinity. The solution to when is the line 2x minus 3 less than x minus 1, that's going to be the interval from negative infinity up to 2. And so for the last part, for part C, 2x minus 3 is greater than x minus 1. So when is the blue line above the purple line? That happens from 2 to infinity on the x-axis. So as x goes from 2 to infinity, 2x minus 3 is greater than x minus 1. And if you solve these things algebraically, you're going to get the same answer. The main point about this is what it's asking you to do is to solve it graphically. So show a picture of what's happening here.